Ever wondered how doctors crack the code on rare diseases, conditions that affect just 1 in 200 people, but can be life-changing? It's like searching for a needle in a haystack. But now, a groundbreaking AI system called DeepRare is turning that haystack into a treasure map. Let's break down how it works and why it's a game changer. Picture this. A patient walks into a clinic with a mix of unusual symptoms, maybe developmental delays, rare physical traits, or unexplained health issues. Traditional methods might take years to diagnose, but DeepRare uses a smart blend of patient data, medical knowledge, and AI to speed things up. Here's the cool part. It doesn't just look at one piece of the puzzle. It combines 3 types of information: free text descriptions of symptoms, standardized HPO terms like a medical dictionary for symptoms, and genetic variant data. The system starts by standardizing the information. For example, if a patient's notes mention delayed speech, the AI maps that to the exact HPO term. Then it uses a memory bank of existing medical data to find patterns. Think of it like a supercharged search engine that learns as it goes. Next, the AI tackles the genetic side. If the patient has a genetic test, DeepRare analyzes the results, ranking variants by their potential to cause disease. But even without genetic data, it can still make educated guesses based on symptoms alone. The system then cross-checks its findings, refining its diagnosis through a process called self-reflective analysis. It's like having a team of doctors double-checking each other's work, catching errors and improving accuracy. What makes DeepRare stand out? It's not just about speed. By integrating clinical expertise with cutting-edge AI, it's bridging a critical gap in rare disease diagnosis. And the best part? The researchers are sharing their tools and data, so others can build on this work. Now, this isn't just a tech demo, it's a lifeline for patients. Imagine a child with an undiagnosed condition finally getting answers, or a family understanding the genetic risks for future children. DeepRare is a step toward a future where no one has to wait years for a diagnosis. Thanks for watching. If you found this interesting, hit subscribe for more deep dives into science and tech. And let me know in the comments, what rare diseases would you like to see us cover next? See you in the next video. Ever wondered how doctors crack the code of diseases so rare, even experts might never have seen them? It's like solving a mystery with half the clues missing. But today, science is giving doctors a superpower, a system that hunts down answers using AI, genetics, and the collective knowledge of the medical world. Let's walk through how this high-tech detective work actually works. It starts with a patient's story. Doctors gather everything they can: medical history, lab results, and crucially, genetic data. But here's the twist. Rare diseases often mimic more common conditions, making them easy to miss. That's where Exomiser steps in. Think of it as a genetic flashlight. It scans a patient's DNA, comparing it to millions of known mutations in databases, and highlights the ones most likely to be causing the symptoms. It's like narrowing down a suspect list when you only have a blurry photo. But genes alone aren't the whole story. That's where Human Phenotype Ontology, HPO, comes in, a universal language for symptoms. If a patient has abnormal heart rhythm, HPO gives it a code, turning vague descriptions into searchable data. This is where AI becomes a game changer. By matching a patient's HPO code to thousands of case studies, systems can spot hidden patterns. Imagine a detective cross-referencing a suspect's fingerprints with a global database. Only here, it's symptoms and genes instead of crime scenes. Now here's the real magic, connecting the dots. A patient's genetic data, HPO codes, and even AI-generated hunches all feed into tools like diagnosis APIs and large language models, LLMs. These systems don't just guess. They act like virtual consultants, pulling from global medical knowledge to suggest possibilities. And here's the kicker. Every suggestion is backed by evidence. Citations pop up like footnotes in a research paper, so doctors can verify each lead. It's like having a library of every medical breakthrough ever made, right at your fingertips. The process is methodical. Doctors input data into Exomiser to filter out genetic noise, then map symptoms to HPO terms, creating a phenotype profile. This profile is cross-checked against similar cases, and AI flags potential matches. It's not a replacement for human expertise, it's a partnership. A doctor's intuition, combined with machines that process data faster than any single mind could, is rewriting what's possible in medicine. This isn't just about solving puzzles, it's about giving hope. For families stuck in diagnostic limbo, these tools are a lifeline. And as AI gets smarter and databases grow richer, the future of rare disease diagnosis isn't just brighter, it's closer than ever.